Children, just beat it. Beat it. Beat it. Beat it. No one wants to be defeated. Showing how funky and strong is your fight.
Hello everyone. Tonight we're talking about finding equations of tangent lines using the derivative. And we'll just start right with a problem. I want to determine the equation of a tangent line to some function f of x at x equals 1, given the function f of x equals negative x cubed plus 3x squared minus 2. Okay, I need to use the derivative to do that. So let's just back up a little bit. If I'm trying to find the equation of the tangent is a straight line. It touches a curve only once. So if I'm trying to find that equation, I'm looking for something in the form y equals mx plus b. So I need two things. I need m, the slope, and I need b, which is the y-intercept. Well, from what we've seen so far, the slope of a tangent is represented by the derivative function. So if I have my function f of x, the derivative of f of x would be f primed at x. And I can find that by applying power rule. So looking at each term individually, so term by term, I'm going to take that exponent of 3 in the first term, bring it down in front, multiply it by the constant of negative 3x, then I decrease the exponent by 1. My first term is negative 3x squared. Do the same thing, bring that exponent of 2 down in front, multiply it by the constant. 3 times 2 is 6. So I have 6x to the power of 1. And then I take the derivative of that constant term, which is just 0. So my derivative function is negative 3x squared plus 6x. If I'm trying to find the equation of the tangent at x equals 1, I'm going to find the slope of this function at x equals 1. So into the derivative function, I'm going to sub value of x equals 1, and I end up with negative 3 plus 6, or f primed of 1 is equal to positive 3. And this is the slope of the curve at x equals 1. So I can build up my equation of the line. If I'm looking at y equals mx plus b, and I've just found the slope, I can sub that in, so I know y equals 3x plus my y-intercept. Well, to find the y-intercept, I still need another point. And to find that point, I can use f evaluated at 1. F evaluated at 1 is equal to negative 1 cubed plus 3 times 1 squared minus 2. So that works out to negative 1 plus 3. Take away 2, or 0. So I know one of the points on this tangent line would be the point 1 and 0. So I can take this point and I can sub it into my equation of a line for x and y. So when y is 0 and x is 1, I can solve for b. So simplifying this, I get negative 3 equals b, which means that the tangent to f of x at x equals 1 is the equation y equals 3x minus 3. Okay, a similar question, where on the function f of x, and we'll use the same function as our previous example, are the tangents horizontal? So where on this function are tangents horizontal? A horizontal tangent means that the slope of the tangent, f prime of x, equals 0. So we found f prime of x in the previous question. It's equal to negative 3x squared plus 6x. And we're trying to find where this derivative function is equal to 0. And we can do that by factoring. So factoring out a 3x, or a negative 3x from both terms, I get a factor of negative 3x, and a factor of x minus 2. So I can take each of these factors and set them equal to 0. So 0 equals negative 3x, and 0 equals x minus 2. And by solving each of these two equations, I get 0 equals x, or 2 equals x. And these are the two x values where the slope of the tangent is 0. We're asked where on this function the slope's 0. So what we're looking for is an answer that's a point. So we need to find f evaluated at 0 and f evaluated at 2. And you can try that on your own, and you should get a point at 0 and negative 2, and a point at 2 and 2. And we can even verify this by graphing. And Google does a good job of graphing now. So I can graph y equals negative x cubed plus 3x squared minus 2. And looking at this, I can see that it would be a horizontal tangent at 0 and negative 2, and another horizontal tangent at 2 and 2. Okay, one last example. we're finding a point on the equation y equals 3x squared times the square root of x, where the tangent is parallel to this line, or, in part B, where the tangent is perpendicular to this line. We'll do A first. If the tangent is parallel, then we're looking for something with the same slope. So looking at that equation, y minus 60x plus 3 equals 0, I can manipulate this to solve for y, and I can see that my slope is 60. So I'll take that equation y, which is equal to 3x squared times the square root of x, and I want to find the derivative of this, but we need to first manipulate this into one term. So the square root of x is the same as x to the power of 1/2. And recall, when you multiply variables together that have the same exponent, you add the exponents. So this becomes 3 times x to the power of 5/2. And now I can find the derivative. I can find dy by dx, and that's equal to 3 times 5/2 times x to the exponent of 5/2 minus 1, or the exponent of 3/2. Simplifying that, I have 15 over 2 times x to the 3/2. So this is the equation of my derivative. I'm trying to find when that derivative is equal to 60. So I'm trying to find when 60 is equal to 15/2 times x to the power of 3 over 2. So we're going to do some bedmas here to solve for this, some backwards bedmas. I'll bring up the 2. So 60 times 2 equals 15 x to the power of 3/2. Divide both sides by 15, so 60 times 2 divided by 15 equals x to the power of 3/2. So simplifying this, I get 8 equals x to the power of 3/2. And now to reverse this power of 3/2, I'll square both sides and then take the third root. So x would be the third root of 8 squared, which can be solved down to 4. So try that on your calculator. X equals 4. Again, I'm looking for a point. So I'll take that value of x equals 4 and I'll sub it into my original equation, 3x squared times the square root of x. So 3 times 4 squared times the square root of 4 becomes 3 times 16 times 2, which is equal to 96. So the point where the tangent is parallel to that equation of a line is at 4 and 96. In part B, we're finding the tangent that's perpendicular to that line. Perpendicular slopes, recall, are negative reciprocals. So again, taking that equation of the line, 2x plus 405y minus 4 equals 0, and rearranging this to solve for y, to see what that slope is. I can see that my slope is negative 2 over 405. If I want the negative reciprocal, if I want the perpendicular slope, I can take this fraction and I can flip it and multiply it by negative 1. So my perpendicular slope is 405 over 2. So my perpendicular slope is 405 over 2. Going back to my derivative equation, I need to solve for x when the derivative is equal to 405 over 2. So 405 over 2 equals 15 over 2 times x to the power of 3 halves. Again, using some bedmess to rearrange this, end up with 405 times 2 over 2 times 15. That equals x to the power of 3 halves. Some terms cancel. And 405 divided by 15 is 27. And that equals x to the power of 3 halves. Again, the third root of 27 squared will be equal to x. Solving that on my calculator, I get 9 equals x, which I then need to sub into my equation that I started with. So y equals 3 times 9 squared times the square root of 9. You should get 729. So we can say that the point is 9 and 729. That's the point where the tangent to our original curve is perpendicular to the line we were given. And that's all I want to do today. Tomorrow in class, there'll be several homework questions that you can practice. We need to continue practicing how to find derivatives. That's going to be the bulk of our work for the rest of this course. You need to be good at it. You need to be quick at it. So if you are finding that you're running into trouble or can't follow along with what I'm doing, you need to make sure you let me know so that we can do some work together.